video, we'll be going over Review 2 in the workbook, pages 41 to 45. The first question tells us to write the following in words. So it says the number in standard form, and we need to write it in words. So I went ahead and wrote these, so I didn't take the time on the video to do that. So 2 million, so this is in the millions place, so that's 2 million. These are the thousands, 44,000. 44,000. Remember to use a hyphen for any numbers 21 to 99. The next one we have millions and thousands. So we have 15 million and 508,000. So we write it 508,000. We have no hundreds, tens, or ones. And the next one we have millions and thousands again. So we have 376 million. So we write it like that, 376 million. And then in our thousands, we have 920,000. So we write 920,000. In this last one, we go up to the billions. So 6 billion, and then we have millions, 400 million. No thousands and no hundreds, tens, or ones. Moving on to number 2. Now we have to write the following in figures. So we start with it written in words and we go the other way. 2A says 4,008. So then we're only going to have thousands and then our ones. So I just make my places to make it easier to fill in. 4,000, and then we just have 8 in the ones. So it's 4,008. Letter B. We have 27,300. So again, we're going to need thousands and then our ones. 27,000. So in our thousands, we have 27. And then we have 300 for our ones family. Remember, this is ones, thousands. So we write it like that, 27,300. C, we have 60 billion and 11. So we're going to need billions family, millions family, thousands family, and the ones family. And the billions are 60 billion, and then we have 11. So way over here in the ones, we have 11. We have no millions, no thousands, no hundreds there. So we write it like this, 60 billion, no millions, no thousand, and 11. And then D, 12,904,000. So we have millions family, thousands family, and then the ones. Again, let me label those. Ones, thousands, millions. And then we can just fill in what we have. We have 12 million. And then we have 904,000. So 904, that goes in the thousands. 0 ones. So we write it like this. Okay, number 3. Find the value of each of the following. So it has 500,000, and then it has 80,000, and I'm just going to write these vertically. You don't have to, and then 300. So you could line them up like this and just add them, and you'd get 580,300. Or you can kind of just think about it in your head. If you have 500,000 and 80,000, add your thousands and you get 580,000, and then just add on the 300. So 80,000, 300. If you can't do that in your head, you can do it vertically. So for B of that same problem, again, if you can't do it in your head, do it vertically. 60 million plus 420,000 plus 5,000. So we only have the 60 millions. For our thousands, we have 420, and then we have 5, so 425,000. Or you can just do that in your head, noticing that 60 million is the only thing in the millions place, and then we have 420 for the thousands and also a 5 for the thousands, so 425,000. 60,425,000. Number 4A. In this number, 8,453,000. The digit blank is in the hundred thousands place. So let's just label our families here. We have the ones family, the thousands family, and the millions family. And they want to know which digit is in the hundred thousands. So if these are our thousands, we have the 1,000s, the 10,000s, and the 100,000s. So the digit 4 is in the 100,000s place. And then letter B, we're given another number, 5,236,000. And the digit 3 stands for 3 times what? So this digit 3 is 3 times what? So this digit 3 is in the 10,000s place because we have our thousands family here and our ones family. So this, the 6 is the 1,000, the 3 is the 10, and 2 is the 100,000. So the 3 tells us how many 10,000s we have. We have 3 10,000s. So its value is 3 times 10,000. The answer is 10,000. Number 5, we're looking at big numbers again. We have 8,206,000 is 1 million more than what number? So if it's 1 million more than a number, this number is actually 1 million less than that. So if we just take a million away from the 8, we'd have 7 million. So 7,206,000. You can check if that makes sense. So 1 million more than 7,206,000 would be 8,206,000. So that's right. The next one, we have 62,440,000 is a million less than what? So now we need a million more than this. So we add a million. 62 plus 1 is 63. So 63,440,000. And we can check again if it makes sense. Is 1 million less than 63,440,000? 62,440,000? Yes, so that's right. This one's a little bit harder. 9,345,000 is how much more than 9,305,000? So the difference of those, if we look here, one has a 4, this one has a 4 in the 10,000s place, and this one does not. So this number is going to be 40,000 more than that number, because this 4 is really 4 times 10,000, or 40,000. On this one, we have 7,188,000 is how much less than 7,988,000. So again, our different numbers here. We have a 1 in the 100,000s place here, and a 9 here. So the difference between the 100,000 and the 900,000 is 800,000. So that number is 800,000 less, whoops, another 0, than this number. Number 6, we just want to know which is greater. So they both have the same number of thousands. They both have 45,000s. But then the hundreds, this one has 8 and this one has 3. So this number is going to be bigger. On the next one, it wants to know which is smaller. So again, they both have the same number of thousands. We have 30,000 in each case. So now we go on to the hundreds place. This one has 0 and this one has 1. So this one would be smaller. Whoops, that's smaller. So this one is smaller. This one is greater. And then number 7 asks for arranging the numbers in decreasing order. So decreasing means start with your largest. So all we really need to do is look in the thousands here. So we have 64,000 in something, 76,000 in something, 87,000 in something, and 60,000 in something. So our most thousands are 87. So this is your largest. That'll be your 1. Then the next largest would be our 76,000. And then after that, our 64,000. And then our smallest thousands is 60,000. So it'd be 1, 2, 3, 4 on that one. Now we need to know the factors of 24. So this is where I like to just make a little chart here. I just go like 1 times 24, and then is 2 a factor? Yes, it's even, so 2 times 12. Is 3 a factor? Yes, 3 times 8. And again, our rule, if you add up the digits and it's divisible by 3, then the number is divisible by 3. So 2 plus 4 is 6. That's divisible by 3, so 24 is divisible by 3. And then I also have 4 times 6. So my factors are 1, 2, 3, 4, 6, 8, 12, and 24. Now we need the first 12 multiples of 6. So that's counting by 6, or you can think of your multiplication facts. 6 times 1, 6 times 2, 6 times 3. So we have 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, and 72. I think that's 12. 1, 2, 3, 4, 5, 6. Yep, so this is like 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, all the way up to 6 times 12, which is 72. Number 9 just has us find the smallest number, and as you can see, they're all into the 10,000s, so we can just compare the number of thousands. We have 90,000, 84, 91, and 80,000. So 80,000 is the least of those. That is the smallest. Now we need to find the value of all of these, and we're going to be using order of operations. The first one is all addition, so we can add in whatever order we want because it's just addition. This is where you find numbers that go together well, like 50 and 50 is 100, and then 130 and 70 is 200. So then we just need to add the 20. So 200 plus 100 is 300 plus 20 is 320. Letter B, we need to do our multiplication first. That's 100. So then we can do 145 minus 100 is 45. This one we can just go straight across because we just have multiplication and division. So we can first do 228 divided by 6. And we get 38. And then we can do 38 times 2, and I think I can do that in my head. 30 times 2 is 60, 8 times 2 is 16, so 60 plus 16 is 76. On letter D, we need to do our division first. 45 divided by 9 is 5. 306 minus 5 is 301. Letter E, we need to do our division first. 36 divided by 6 is 6. So now we can go straight across. 440 minus 64. I go off to the side. Alright, I need to take a 10 to get some 1s here. And then I take 100 to get some 10s. And I get 376. And then I just need to add the 6. And I will get 82. 382 on that one. On letter F, I have to do parentheses first. This is our first one with parentheses. Parentheses always comes first. 5 times 4 is 20. Now I need to do multiplication and division from left to right. Here we have 20 divided by 20 is 1. And then I can just do 8 minus 1, which is 7. Letter G. I don't have any parentheses, so I go left to right, multiplication and division. I can do 16 divided by 4 is 4, and I can do 1 times 2 is 2. I'm going to bring down my numbers. 8 minus 4 plus 2. 8 minus 4 is 4, plus 2 is 6. Letter H, I'm going to do multiplication and division left to right. 21 divided by 7 is 3. 3 times 9 is 27. And I bring down my other numbers. 41 minus 3 plus 27. 41 minus 3 would be 38 plus 27. 38 plus 27 would be 65. Letter I, we have no parentheses, so we'll do our multiplication and division from left to right first. 3 times 6 is 18, and then I have a 10 divided by 5 is 2. Bring down my other numbers. Now I can just go left to right, add and subtract. 18 minus 12 is 6, plus 2 is 8. Now we have a parentheses. Got to do that first. I'm just going to write this, bringing everything down. Now I go left to right, multiplication and division. So 7 divided by 7 is 1, and then 1 times 3 is 3. So I end up with 4 minus 3 is 1. Now we have some exponents. 3 to the 4th times 5 squared. 3 to the 4th means 3 times 3 times 3 times 3. And then 5 squared means 5 times 5. So I'm going to do 3 times 3 is 9. 3 times 3 is 9. So then 9 times 9 is 81. 5 times 5 is 25. So I end up with 81 times 25. That I cannot do in my head, so I am going to multiply it out. Sorry for the technical difficulties there. When I finished multiplying 81 times 25, I got 2025. Number 11 asks for the prime factorization of 200. So remember, with prime factorization, we can start with any two factors and then keep breaking them down until we get all prime. So with 200, we could do 2 times 100. And then we could break the 100 down into 2 times 50, and then the 50 down into 2 times 25, and the 25 into 5 times 5. Now you could have started with different factors, or any place along the way you could have had different factors, but when you break them down, when you keep going, you should end up with all the same prime factors. So I have 3 2's, so that's 2 to the 3rd power, and then 2 5's, so 5 squared. So the answer is 2 to the 3rd times 5 squared. Number 12 says to round 49,501 to the nearest hundred. So our hundreds place is here. So we'll either leave it as 500 or we'll go up to 600, and we look to the next digit to determine that. Since it's a 0, since it's less than 5, we keep it the same. So it's 49,500. Now we need to round it to the nearest thousand. Here's our thousands place. We look to the next digit to determine if we round up. If it's 5 or more, we round up. So it is 5 or more, it's 5, so we round up. So the next thousand after 49,000 would be 50,000. Here we just need a sum. We're just adding. So we see this 900. That 900 is just going to go in the hundreds place. And we're going to get 12,999. You could have added them up vertically if you needed to. Here we're looking for a difference, so we're subtracting 79 from 2100. This one I would do in my head, but if you can't do it in your head, you can do it vertically. In my head, I would just say, what is 100 minus 79? And I know that's 21. So then 2,100 minus 79 would be 2,021. But again, you can subtract that vertically if you need to. C, we're looking for a product, 540 times 28. So here we need to first multiply by the 8. 0 times 8 is 0. 4 times 8 is 32. 5 times 8 is 40, plus 3 is 43. Now we multiply by the 20, which means we multiply by 2 and then by 10. So the by 10 part means we add a 0 here. Now we multiply by 2. 2 times 0 is 0. 2 times 4 is 8. 5 times 2 is 10. We add, and we get 15,120. Our last problem on this page is finding a quotient and remainder if we take 127 divided by 40. If I round 127 to 120, then I can divide that easier because 40 times 3 is 120. So I'm going to use 3. 40 times 3 is 120. Whoops. And I have a remainder of 7. 3 remainder 7. Now we have some story problems. Number 14, 200 children took part in a concert. There were 4 times as many girls as boys. How many girls were there? So this is a great bar model problem. We have 4 times as many girls as boys. So our boys will be represented like that, and our girls have 4 times as many. So they have 4 of that same equal part. And then all together there are 200 kids. So the question is, how many girls were there? So if we take 200 and divide it by these 5 equal parts, we would get 40. So each of these are 40. And then the question is, how many girls? So 40 times 4. So 4 times 4 is 16. So 40 times 4 is 160. How many? That's part A, is 160 girls. And part B asks how many more girls than boys. So the boys have 40, the girls have 160, so there are 120 more girls. Okay, turning the page to 15. Miguel had 45 melons. He sold 25 of them at $6 each and sold the rest at $4 each. How much money did he receive? So if he has, so he sells 25 at $6 each. So 25 times 6, because each of them he sold for $6. And we get 150 for that set of melons. Now he sold the rest. So 45 minus 25 would be 20. So he had 20 more to sell, and he sold those at $4 each. So that's 80. So if we add that, we would get 230. Number 16 says Ashley bought a bed for $295. She also bought 2 mattresses at $65 each. She gave the cashier a $500 note. How much change did she get? Okay, so basically we just have to add up everything she bought. So she bought 2 mattresses at $65 each. So if I add those, I get 130. And then she also got a bed for $295. So $425 altogether. She gave the cashier $500, How much change did she get? Well, she owed $4.25, so she'll get $75 and change. Number 17, Brandy has 278 stamps. Jane has 64 stamps more than Brandy. Sam and Jane have 500 stamps altogether. How many stamps does Sam have? Okay, so let's see here. So Brandy has 278. Jane has 64 more than Brandy. So Jane has 278 plus 64. So we add those, and we get 342 stamps. And then it says Sam and Jane have 500 altogether. So if Sam and Jane have 500 and Jane has 342, to find Sam we just subtract 500 minus 342. So we get, let's see here, 158 stamps for, these are the stamps that Sam has. And in our last question, 18, Mrs. Peters baked 156 fruit pies for a fruit fair. She sold them in boxes containing 12 fruit pies each. Each box cost $18. How much money did she collect? Okay, so we have to find out how many boxes she sold, and there's 12 pies in each box. So if we take her total number of pies and divide by 12, we'll find out how many boxes. We get 13 boxes of pies. Each box costs $18. So if we multiply the 13 times the 18, we'll get the total money. $234 for the boxes. I know there was a lot on this review and there were some challenging questions, so I just want to give you some tips on what to study and make sure you know for the test. I'm going to go over problems that I think you are likely to see on the test. You're likely to see something like number 1, where you have to write out a number in words. You're likely to see something like part 4A, where you need to tell me a digit in a certain place, so I know you understand place value. Number 7, I will probably ask you to write numbers in decreasing or increasing order. I want you to know how to find factors of a number, like number 8, and also multiples of a number. And number 10, what's looking at order of operations, you are for sure going to see a few of those problems where you need to use order of operations, doing parentheses first, then multiplication and division left to right, and then add and subtract left to right. You need to know how to do a prime factorization. I will have at least one problem where you're multiplying by a 2-digit number, like 3-digit times 2-digit number. And then also a division problem. I will have a long division where you're dividing by a 2-digit number, and probably one story problem. So that's what you should kind of focus on. Make sure you really know those problems when you are preparing for the test.
Y-E-A-H. Yay for math!